Hi everyone, welcome to this lesson on angles of elevation and depression. Now before this lesson, you really need to know your trig ratios for right triangles. You need to know sine, cosine, tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you also need to know for this lesson how to find sides of a right triangle using those trig ratios, how to find missing angles of right triangles using those ratios with the inverse sine, inverse cosine, inverse tangent functions. And you also definitely need a calculator, a scientific calculator. It can be on your phone, laptop, a real calculator. It really doesn't matter as long as you know how to manipulate the buttons. I'm going to be using my virtual TI-84 graphing calculator on the computer to show you those keystrokes as I do this lesson. So first of all, angle of elevation means that it's the angle between the observer's line of sight and a horizon line. So here, if I had two parallel lines and I have this transversal here, this is where the angle of elevation is. It's from the line of sight up into what you're actually looking at. So if I was looking up at a cloud, my angle of elevation would be the angle from my eyesight up into where those clouds are. And it's really important to make sure we know that this is where the angle is. It's always between the horizontal line and the transversal. We want to make sure we don't think that an angle over here that I'm kind of pointing to right now is the angle of elevation. Now, something you should look at is, hey, remember when we were talking about parallel lines and a transversal? Well, excuse me, isn't this angle here, the angle of elevation, the same as this angle up here? And remember, those are alternate interior angles, which leads me to the angle of depression. That's actually where the angle of depression is. So if you were standing somewhere and you were looking downwards, the angle of depression is this angle from your line of sight, your horizon, to where you are actually looking. And it's this angle here. I know that looks so weird. That, excuse me, is where your angle of depression is. So it's this specific place between the horizontal and the transversal, not this angle here. That's between the transversal and just some open space or a vertical line. And then, of course, notice that the angle of depression is actually the same as the angle of elevation. They're alternate interiors. So I've got a few word problems for us. When I give you a word problem, I'm going to give you a moment to try to draw out what you think the design might look like. So after I read the problem, you may want to pause, see if you can sketch out a diagram, and then press play and see if you have your diagram correct before you move on. So first it says the angle of elevation from point X to the top of a building is 52 degrees. If point X is 125 feet from the base of the building, how tall is the building? So if you want to press pause right now and try to sketch out what you think this may look like, please do. Otherwise, you can always, of course, just follow along with me. So the way this diagram really should look is like this. And I just need to go over a few things that did not scan well in my diagram. So first of all, we have this line here. We've got a line here, a line here. And something else we need to kind of remember is that we're always going to be dealing with horizontal lines. So it says here the angle of elevation from point X, so here's where I have point X, to the top of a building is 52 degrees. So notice where the 52 is. It's between the transversal, okay, the angle of elevation looking up, it's between the transversal and the horizontal line. If point X is 125 feet away from the base of the building, so this length here, from X to this point here, is 125 feet from the building. How tall is the building? So I'm going to label this Y. That's what we're trying to figure out. If you're looking at a building at a 52 degree angle of elevation and you're 125 feet from it, how tall is that building actually going to be? So what we have to think about here is look at the angle. Look at what we're trying to solve in relation to that angle. This is the opposite. And then we need to look at the value we're also given and notice that's the adjacent. Notice we're not worried about the hypotenuse at all in this figure. Which trig function uses opposite and adjacent? Well, it's tangent. So tangent of 52 is equal to opposite over adjacent. So y over 125. And then we've looked at this before in a previous lesson on trig ratios, how to solve this and set this up. So I would go ahead and multiply both sides by 125. Then I would get 125 tan 52 is equal to y. Now I'm going to show you in my calculator here. I'm just going to move this over a bit. So I just really have the calculator here for you. So what I am doing is I'm typing in tan 52. So a couple of things. Your calculator may require you to do 52 first and then press tan. If you're working with a graphing calculator, you can type in tan 52, press enter. And something we're going to notice here is that definitely doesn't look right, which actually means I'm in the wrong mode. So this is a learning lesson. If I showed you my calculator right here, you see at the top it says radians. If you're getting a negative, something's definitely wrong for this, because when I go to multiply a negative times that value, I'm going to get a negative. It means I'm in the wrong mode. So you need to go over to mode and make sure that you select the function that you are in degrees. And as long as it says degrees, then you know you're going to be good. So I'm going to go back to my home screen here. And now I'm going to type in tan 52 again. And what you will notice, and I will notice, is I get a definitely more appropriate answer. Okay, so if I get tan of 52 is 1.2799, remember, don't round this off, leave it fresh in your calculator. And then I'm going to multiply it by 125. And that is going to be my answer. So my building is approximately, if I wanted to round to the 10th place, 160 feet tall. Okay. If you were using a calculator on your phone or a calculator on the computer, again, you'll notice it says degrees. That's what you want it to say. If it says radians like that, you just click on it, turn it back to degrees, and then you're good. You would type in 52, click. Let's see, we need our trig functions. We need tangent. And then we get that same number we had before, and then multiply by 125. And you can see we get the exact same answer. Okay, guys, so now this next problem is a bit of a doozy, so bear with me. It says, Olivia stands on the street and looks at the 4th floor of a building at a 50-degree angle of elevation. She then steps back 15 feet and looks at the 4th floor at a 40-degree angle. If Olivia is 4 feet tall, how tall is the 4th floor? There's a lot going on here. Now, first of all, here is what a diagram would even look like. And this is something, the first time you see these problems, I would never expect a student of mine to just draw the diagram exactly the way it looks. But let me explain, so in case we come up with another problem with some part of this, you've already now seen it. So first, Olivia was here, and she's looking at a building at a 50-degree angle of elevation. So we already know where the 50 goes. She then steps back 15 feet. So there's a length of 15 feet. And now here is Olivia again, now for the second time. And she's looking at that same point at the top of the 4th floor, but now at a 40-degree angle. And now it would make sense. I mean, if you were looking at something and you were close up, you have that angle there. And if you go backwards, that angle is going to get smaller. Okay. And we do know that Olivia is 4 feet tall. So the angle of elevation is obviously coming from her eyesight. It's not coming from her toes. So we have to make sure that this diagram, all these pieces together, and really works. And now it's saying, how tall is the 4th floor? So we're going to be able to set up some ratios here to solve for x. And that's going to tell us the height from her eyes to the top of the 4th floor. But then we're going to also have to account at the end for her 4 feet of height and figuring out how tall the entire building is. So first off, I'm labeling the height of the building by her eyesight as x. Now, that's not the full height of the building. That's, of course, just the height at her eyesight. So it's really the height of the building minus the 4 feet. And some ratios I can set up are figuring out, this length here in relation to how far away she is from the building originally, and then knowing that she's going to step back an additional 15 feet at a 40-degree angle and setting that up. So notice what we have. So from the angle of elevation, we have opposite, still opposite over adjacent. And so this is going to look like tan of 50 is equal to x over y. And now the second one we can say is then tan of 40 is equal to the opposite of from 40 is x. But here's the whole adjacent. The adjacent is not y, it's not 15, it's the entire length here of 15 plus y, or y plus 15. Now, think about what's happening here. Both of these equations have x in them, both have y in them. So we actually are going to set up some sort of a system, but we at least need to be able to substitute somehow. So we can get both of these equations to be solved for x. So if I wanted to solve the first equation for x, I would have to multiply both sides by y. And if I multiply both sides by y, I'm going to get y tan 50 equals x. If I multiply both sides of this equation by y plus 15, I'm going to get y plus 15 in parentheses times tan 40 is equal to x. Now think back to systems of equations from Algebra 1. If you have two equations both set equal to x, then you can set those expressions that are equal to x equal to each other. So I can substitute y tan 50 in for x into that second equation. And now I have y tan 50 is equal to y plus 15 times tan 40. Okay, so y tan 50 I can do nothing with for right now. And then y plus 15 times tan 40, that tan 40 is going to get distributed to the y. And at this point, you're like, where is this even going? Oh my gosh. Okay, and so now we have this. And now notice x is obviously gone in our equation because we use substitution, so we only have y. So the whole thing would be, it would be good to actually be able to solve for y, right? But right now we've got y on either side of our equation, and y is being multiplied by tan 50 and y is being multiplied by tan 40. So what we need to do is we need to get the y's on the same side of the equation. So I'm going to actually subtract y tan 40 and send it to the left-hand side. So it looks like this. And now because they both have a y in common, think about factoring out that common factor of y. So if I factor out a y from both of these terms, in parentheses, I'm going to be left with tan 50 minus tan 40. You're like, oh my gosh, is this done yet? We're almost there. So now if I wanted to solve for y, since y is being multiplied by this expression, I would then have to divide both sides of this equation by this entire value in parentheses. And this is what we get. We end up getting that y is going to be equal to 15 tan 40 divided by tan 50 minus, that says tan 40. All right, so let's pull up my trusty calculator. Ready? And I'm just going to scooch this over. So 15 times tan of 40. I'm going to press enter. Okay. Now I'm going to take that answer. That's nice in my calculator. I'm not rounding it. Notice again, it says degree. If you're in radians, make sure you switch it to degrees. I'm going to click divide. And now in parentheses, I'm going to type in tan 50, close the parentheses for the 50, minus tan 40, close the parentheses for the 40, and then close the beginning parentheses and press enter. So y is equal to this 35.69 number. So I'm going to write that down. Oops. Get rid of that. And so what I have right now, it's a rough estimate. I'm going to call it 35.69, just so it's a little bit more clear. So my y is 35, I forgot already, 35.69. And that's my y, but now I need to find x. So now I can say, okay, well, if my y is this, right? I can substitute my y in here and solve for x. So tan 50 is equal to x over y. So that means x would be equal to that number of 3569 whatever multiplied by tan 50. And a good idea is always, guys, whatever you have in your calculator, just leave it there because you may need it later. So right now I have that value. I didn't mess with it. And now I can just take that fresh value, multiply it by tan 50. And so my x is now 42.53. And now if x is this value here, 42.53, but I want to know how tall is it to the top of the 4th floor, I have to add that additional 4 feet of height. That's right here. And I get 46.53 feet. There's a lot going on there for sure. Okay, next question. Question. I said pression. Problem question. Okay. Find the angle of depression of the sun when a 2-meter tall student casts a 4.5 meter long shadow. So the student is 2 meters tall. The shadow is 4.5 meters tall. So if I was to draw this out, here is what it may look like. So here's the sun. Here's a person who's 2.2 meters tall. The shadow is 4.5 meters tall. And what I want to find is, what's the angle? Like, what angle of depression do I need? And it really doesn't matter what place in the diagram you put x for the angle of depression. This is technically the angle of elevation, but we learned they are the same thing. So if you were drawing a diagram and you said, okay, well, I know that from the sun, here's the 2 feet, that this is where my angle of depression is, but it's outside of this triangle I'm drawing, I may as well put that same x value here. So the angle of depression is the same as your angle of elevation. And now looking at what we have, if I want to solve for my angle, I would say, okay, well, from the angle I need to solve, I do have an opposite and I do have an adjacent, which means, again, I'm still using tan. So what I'm going to say is, okay, well, tan of x is going to be equal to 2 over 4.5. And so remember, when you go to find the angle measure, we're going to say the inverse tan of that function is going to give us that angle. So I could even add in here, the measure of angle x is equal to the inverse tan of that ratio. Okay, and I wrote it as x after, just given that it's going to be the measure of that angle. And now let me show you what this should look like. So I'm going to clear out my calculator. Let me scooch it in here. So when I want to do inverse tan, you have to make sure inverse tan is the second function. So above the tan, you're going to see in blue, or on your calculator or phone, you're going to see you have to press the up arrow. I'll show you in a moment. So I'm going to do second inverse tan. 2 divided by 4.5, close parentheses, and I get 23.96. And so I'm going to call that about 24 degrees. Okay, if I pulled up the calculator on my laptop or my phone, your phone, iPhones, guys, it's going to be the same thing. So what you need to do is you need to click into trigonometry. Actually, first you need to click the up arrow. So let me make this a little bit bigger. In this case, it's going to be second. So to access the inverse tan, you're going to click second, and then that's going to bring you the inverse tan button. And then 2 divided by 4.5. So I'm going to do 2 divided by 4.5, press enter, and then we have to go into the trig function after, click second, and then tan. So always remember, that's how your iPhone and your calculator and your laptop are going to go. You have to type in the number first and then apply the inverse function. We went over that in a previous lesson. And you see I get the exact same answer. I just rounded to the nearest whole number. Okay, a skateboard ramp is 25 feet long with a vertical drop of 20 feet. Find the angle of depression from the top of the ramp to the bottom of the ramp. So the skateboard ramp itself is 25 feet long. So think about a ramp. If that's going to be your hypotenuse. you've got a vertical drop of 20 feet. Okay, find the angle of depression from the top of the ramp to the bottom of the ramp. So here is the angle of depression, but we also know that the angle of depression is the same thing as the angle of elevation, so that these are the same. So if I'm finding the angle of elevation, the depression, I can really mark it up as elevation. And now notice what we have here. Based on this angle, I have opposite, but now I have hypotenuse. So which trig function deals with opposite and hypotenuse? Do we remember? We haven't used it yet. It is sine. Sine is opposite over hypotenuse. So we're going to say the sine of x is equal to 20 over 25. We're then going to say, okay, well then the inverse sine of 20 over 25 is actually going to give us the measure of that angle. So I'm going to go ahead and click into my calculator again. On the graphing calculator, you can just type it directly in. So second inverse sine, 20 over 25. Press enter. I get 53.13. Okay. If I was to pull up the calculator on the computer, I would have to do 20 divided by 25. Then go to trig, second, and do my inverse sine. And notice I get my exact same answer. Okay, from the 10th floor of a 100-foot tall building, Nathan watches the start of a parade at an angle of depression of 65 degrees. How far away is Nathan from the start of the parade? So Nathan's at the top of this building. He's looking downwards at an angle of depression of 65 degrees. How far away is Nathan from the start of that parade? So if this is where Nathan is, okay, Nathan is at this point here. He's looking down at an angle of depression of 65 degrees. The building that he's on is 100 feet tall. We want to know the hypotenuse. We want to know how far away is he from the start of this parade. Now, of course, if it's an angle of depression of 65, we know that if this is 65, then this is 65 in this right triangle. Based on what we're given, we are talking about the opposite and the hypotenuse. So again, we know that's sine. So I'm going to say sine of 65 is equal to the opposite, which is 100, over the hypotenuse. Now here is an example of a problem where, to solve for x, there's a couple different ways we can look at this. So to solve for x, because x is in the denominator, we would need to multiply both sides by x. And then remember what happens there. These x's will simplify out. So you're left with x sine of 65 equals 100. But then to solve for x, we need to divide both sides by sine 65. So imagine that I divided by sine 65, divided by sine 65. I know it's super sloppy. And so this is what we have to type in carefully. So I'm going to do it on the TI first. So 100 divided by sine of 65. Okay, I get 110.3377. So I wrote it as 10.3. I'm sorry, 110.3. If I'm in my calculator here, I have to do 100 divided by. Now type in 65, then click sine. And then, so you can see on the screen, that's how you type in 100 divided by sine 65. So 100 divided by, type in 65, then sine, but you're not done because that number on the screen is actually the sine of 65. Now we have to press enter, and then we get our answer of 110.3. Okay, good. I think we're all done for today. Thank you so much for watching. Bye.